ಸರ್ವೇಭ್ಯೋ ದೇವೇಭ್ಯೋ ನಮಃ. ಆನ್ಲೈನ್ ಟ್ರೈನಿಂಗ್ KCET 2021 ಈ ಶ್ರೇಣಿಯ ಮುಂದುವರಿದ ಭಾಗಕ್ಕೆ ನಿಮಗೆಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, I hope you're all fine and getting mentally stronger and stronger as far as the preparation for the KCET 2021 is being concerned. Dear students, this is the session on chemistry. Today I'm going to discuss the topic hydrocarbons. This is the first PUC topic. CET ಪರೀಕ್ಷೆಯಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿರುವ ಹಾಗೆ ಒಂದು 25% of questions they appear from first PUC text. ಹಾಗಾಗಿ ನೀವು ಅದನ್ನ ಇಗ್ನೋರ್ ಮಾಡುವ ಹಾಗಿಲ್ಲ. ಇನ್ನೊಂದು, so today's aspect is going to be from organic chemistry section. So organic chemistry which involves the reactions. So ಎಲ್ಲ ಒಂದು ಕಷ್ಟ ಹೇಳುವಂತ ಭಾವನೆಗಳನ್ನ ಇಟ್ಕೊಳ್ಳದೆ ಒಂದಿಷ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಹೆಚ್ಚಿಗೆ ಮಾಡಿದ್ರೆ ಪ್ರಾಕ್ಟೀಸ್ ಮೇಕ್ಸ್ ಮ್ಯಾನ್ ಪರ್ಫೆಕ್ಟ್ ಅಂತ ಅದಷ್ಟು ಬೇಗ ಆ ಸೆಕ್ಷನ್ ಬರುವಂತಹ ಕ್ವಶನ್ಗಳಿಗೆ ನೀವು ಉತ್ತರವನ್ನು ಕೊಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ. So with that information, myself, Mr. Ganesh N Hegde, lecturing chemistry from Uttarakhand district. So now let's start the session, dear students. About the contents, let's see ಏನೆಲ್ಲ ಓದಿದೀವಿ ನಾವು ಇಲ್ಲಿ ಅಂತ ತುಂಬಾ ಕ್ವಿಕ್ ಆಗಿ ರೀಕ್ಯಾಪ್ ತಗೋಣ. About alkenes we studied. We started with alkenes, which contains sp3 hybridized carbon atom having the tidal geometry, carbon-carbon single bond called as paraffin, showing little activity. And then we moved on to alkenes, which contains carbon-carbon double bond. Look at this, the way it is looking like. So now then alkynes having carbon-carbon triple bond, the presence of pi electrons in both alkenes and alkynes making much more reactive than the alkanes. And the topic ended up with the aromatic hydrocarbons. Tumba basic agi benzene ಬಗ್ಗೆ ಒಂದಿಷ್ಟು reactions ನಾವು ಓದ್ಕೊಂಡಿದ್ದೀವಿ. So now there's a bunch of reactions. I'd like to give a list of that now, dear students. Substitution reactions we have studied here in the topic, right? As far as the alkene is being concerned, we have studied the substitution reactions with the free radical. So that was free radical substitutions we call as. Then aromatization, the conversion of alkenes into aromatic hydrocarbons with usage of special reagents. When it's a special reagent and then make a list of that, it will be easier to work out any kind of reactions in organic chemistry. So therefore, so now don't forget, as far as the special reagents and named reactions, the kind of the reactions which is going to be very important as far as one certain molecule is being concerned. For example, addition reaction, the typical reactions of the carbon multiple bond. So now, and then ozonolysis, once again the characteristic reactions of both alkenes and alkynes. Now alkenes are especially double bond and trace out malike, I mean locate malike. Yav position ide anta locate malike. This is one of the beautiful reaction. And then dehydrohalogenations, conversion of haloalkenes into alkenes, you know that. One the special reagent, alcoholic potential and petrolic. Oxidations you studied in that particular topic under different conditions. Named reactions sige barodadre. So now in Wood's reactions you have studied. This year also you have studied that thing. So now formation of the higher alkenes in the curriculum. Call-based electrolysis, once again, that is the preparation for the alkenes being concerned. Fredcraft reactions, both alkylation and acylation, we have studied in this particular topic. Reagents, here the reagent and then particularly the reductive ozonolysis use ಮಾಡುವಂತದ್ದು. Lindler's catalyst, that's the pelletized charcoal is being used there. With all these informations, the students, I start the MCQs now. So let's start the question: which of the following general methods can be used to prepare methane? PQRs in the 4 method. Let's try to analyze. Workout ಮಾಡೋಣ. RCONA ಇದೇನಿದು ಹೇಳಿ? Sodium salt of carboxylic acid. Electrolysis ಇದೇನಿದು? Col-based electrolytic method of the preparation of alkenes. So at anode, the respective alkenes are going to be liberated. So now remember this, free radical agi combination of free radical takes place. Remember this, usually in this method, the symmetric alkanes containing even number of carbon atoms are prepared. So andre, especially methane, no way can be prepared from this method. Therefore, ಇಲ್ಲಿ ಆಪ್ಷನ್ ಅಲ್ಲಿ ನೀವು ವರ್ಕೌಟ್ ಮಾಡ್ಕೋಬಹುದು. ಎಲ್ಲೆಲ್ಲ ಪಿ ಇದೆಯೋ ಡೆಫಿನೆಟ್ಲಿ ಇಸ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಚಾಯ್ಸ್ ಅಂತ. ಇನ್ನೊಂದು ಕ್ವಶನ್ ತಗೊಂಡು ಇನ್ನೊಂದು ಮೆಥಡ್ ತಗೊಂಡು ನೋಡಿ. ಈಗ ಆರ್ ಮೆಥಡ್ CnH2n ಅಂತ ಆನ್ ಹೈಡ್ರೋಜಿನೇಷನ್. ಇದೇನಿದು CnH2n ಹೇಳಿ? ಅಲ್ಕೀನ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಯಾವ್ದ್ರಿಂದ ಹೇಳಿ? ಈಥೇನ್. ಸೊ ಈಥೇನ್ yes can be converted into ethane. No way the methane can be produced from this method. Alkene ಇಂದ methane ಬರಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಆಗಲ್ಲ. So therefore ಈಗ ಇನ್ನೊಂದು ಮೆಥಡ್ ನೋಡೋಣ. RCONA, once again this is going to be sodium salt of carboxylic acid. ಇನ್ನೊಂದು ಸೋಡಾ ಲೈಮ್ ಅನ್ಕೊಳ್ಳಿ ನೆನಪಿಗೆ ಬರಬೇಕು. A special reagent ಮೇಲೆ ಫೋಕಸ್ ಮಾಡಿ. This is decarboxylation reaction. It forms the respective alkene. ನಾನೀಗ sodium acetate ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ, right? So now definitely I'll get methane. Right? So Q method ಇಂದ ನಾನು methane prepare ಮಾಡಬಹುದು. ಇಲ್ಲಿ RX ಅಂದ್ರೆ ಏನು ನೋಡಿ? alkyl halide. It's a haloalkene. Simplest member ತಗೋಣ. Yes, chloromethane, bromomethane on reduction in presence of reducing agent like zinc in HCl, it forms methane. So answer ಬಂದಿದೆ. So in the reaction ಅನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ವರ್ಕೌಟ್ ಮಾಡಿ come to the conclusion. Therefore choice C is the answer. Both Q and S methods, they produce methane, but not P and the method R. Let's move to the next question, dear students. So this is number of primary, secondary, tertiary and quaternary carbon atoms present in 2,2,3 trimethyl butane. So but is a word root. ನನಗೆ parent chain ಅದು ಏನು ಅಂತ ಹೇಳ್ತೇನೆ ನೋಡಿ. Whenever there are even number of carbon atom parent chain ನಲ್ಲಿ, this is a bond and structure. ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಳ್ಳಿ, ತುಂಬಾ ಬೇಗ ನೀವು ವರ್ಕೌಟ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ. Even number of carbon atom ಇದ್ರೆ the end carbon atoms are going to be on the opposite side. Look at this. ನಾನೀಗ pentane ಬರೀತೀನಿ ನೋಡಿ. So now the end carbon atom are going to be on the same side. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಇದನ್ನ. So now I'll come to the particular geometry of that. Look at this. Terminal carbon atoms are always going to be primary. ನಾನು ಕೌಂಟ್ ಮಾಡ್ತೀನಿ ಇದನ್ನ. You can look at here. Now 1, 2, 3, 4 and 5. So primary 5 ಬಂತು. Now carbon atom bound to the two other carbon atoms are secondary. Structurally nodi elladru. Now can you find the secondary? There are no secondary. I'll do it here also. Look at this. This is 2, 2 and 3. 2, 2, 3 trimethyl anta helidare. There are no secondary. Therefore 0 aitu. Right? I'll come to the tertiary now. Carbon atom bonded to the three other carbon atoms. Look at this. Now this carbon atom is tertiary. 1 aitu. Now quaternary carbon atom bonded to the 4 other carbon atoms. So now ivala seems to be easy questions, but ello tappunda chances tumba irutte. Number na ನೀವು ಅಲ್ಲಿ ಹೋಗಿ choice ಮಾಡುವಾಗ ತಪ್ಪುಂದ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ. 5011 ಇರುತ್ತೆ, 5100. So therefore be particular. So ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡೋಣ, ಕಂಡೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ ಕರಿತೀವಿ. So therefore better to practice bond line. ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ನೀವು ವರ್ಕೌಟ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಆಪ್ಷನ್ ಡಿ is the correct answer. So now which of the following is non-polar alkene? ಈಗ ನಾನು ಲಾಸ್ಟ್ ಆಪ್ಷನ್ಸ್ ತಗೊಳ್ತೀನಿ. ಇಲ್ಲಿ ಸಿ ಮತ್ತು ಡಿ ದಲ್ಲಿ propene but1 ನೋಡಿ. ಈಗ propene I'm writing like this. The butane I'm going to write ನೋಡಿ. ಈಗ the even number of carbon atoms opposite side ಗೆ end carbon atom ಇದೆ, double bond. Remember this, terminal alkenes are polar always. So now terminal alkenes ಅಂದ್ರೆ ಏನು ಹೇಳಿ? ಒಂದು chain end ಗೆ carbon carbon double bond ಇರುವಂತದ್ದು. So now yes, alkenes are weakly polar. The dipole moment varies from 0.3 dB unit to 0.5 dB unit. So very weakly polar ide. So now we got substituted alkenes in Govana. Substituted alkenes are always going to be more stable than the terminal alkenes ಅಂತ ಹೇಳ್ತೀವಿ. First cis form Govana. They are the geometrical isoforms. ನೋಡಿ ಈಗ cis but2 ನಲ್ಲಿ ಏನಾಗಿದೆ ಹೇಳಿ? The methyl groups are on the same side, right? So now I'll come to the trans form. Look at this. The two methyl groups are on the opposite sides. So now, since they are on the opposite side, in CCH3, the dipole moments, they cancel each other. Therefore, net dipole moment of this particular molecule is going to be 0. Therefore, trans form is going to be non-polar. So now cis form is more polar than the trans form. The boiling point of cis form is high anta heltivi. This is more polar. Solubility kuda this is higher solubility than the transform. So because of the polarity that exists. And stability bandre one point particularly transform is more stable than the cis form. Question might be asked. So actually there exists steric repulsion. Methyl groups are present on the same side. So particularly the transform is going to be more stable than the cis form. Illi particular answer, the option is B is going to be the correct answer. An alkene A on ozonolysis gives a mixture of propanol and Pentane-3-one. Yes, naniga simple agi ee theme takoltini. Ozonolysis andre yes, reactions carrying out by using ozone followed by the cleavage of the complex ozonide using zinc. So now is a reductive ozonolysis. Now in on the substituted similar substitution takoltini. These are I take as a symmetric alkene. Similar. Now in both the cases, aldehyde is going to be the product. Remember, it breaks here. Now complete substitution of the carbon-carbon double bond. The product is going to be here ketone. This is what you remember. Now R groups now there are two different products. So now in the first two cases, if R is same is going to be two similar aldehydes are going to be produced. Illi all alkyl groups are same anta itkovana. Illi two similar ketones are produced. Illi one R different idi bitre. Now two different products are going to be produced. Illi nodi ಒಂದು propanol ಇದೆ, ಒಂದು ಕಡೆಗೆ Pentane-3-one ಇದೆ. So ಒಂದು ಕಡೆಗೆ complete substitution ಇದೆ, ಒಂದು ಕಡೆಗೆ free ಇದೆ ಅಂತ ಅರ್ಥ. Now I write Pentane-3-one ಒಂದು ಕಡೆಗೆ ಬರ್ಕೊಳ್ತೀನಿ ನೋಡಿ ಈಗ 1 2 3. I give the numbering like this, right? So Pentane-3-one. ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಬರ್ಕೊಳ್ಳೋಣ ಪ್ರೊಪೆನಾಲ್ ಅಂತ. ಸೊ ನಾವು ಈಗ ಕರೆಕ್ಟ್ ಆಗಿ ನೀವು ಅಪೋಸಿಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಡ್ರೆ ದಿ ರೈಟಿಂಗ್ ಆಫ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ alkene will be easier. ನೋಡಿ, remove the oxygen atom like this and like this. This is the product going to be obtained. ಕರೆಕ್ಟ್ ಆಗಿ ಎರಡು alkyl part ಅನ್ನ ಜಾಯಿನ್ ಮಾಡಿ with a double bond will get the alkene, right? ನಂಬರಿಂಗ್ ಅನ್ನ ಲೆಫ್ಟ್ ಇಂದ ಮಾಡ್ತೀನಿ ಯಾಕಂದ್ರೆ ಕೆಳಗಡೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಇದೆ. ಸೊ ನಾವು ರೈಟ್ ಸೈಡ್ ಇಂದ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋದ್ರೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ will get the higher number. 6 ಇದೆ, therefore hex ಅಂತ ಆಯ್ತು. Now it is a hexene going to be hexene. Now at the same point it contains the substituent. Option B is the correct answer. Okay, students, work out. You take different aldehydes, different ketones. You get join madi by removing the oxygen atom. Nantra remaining alkyl group na one double bond in the join madi. Try to work out numbering madi. So now adanna name maduvantaha prayatna madi anta ಹೇಳ್ತಾ I'll move on to the next question now. Identify the product P in the following reaction. Isobutene, this is branched alkene. This is how we write it, the bond length structure. Complete structure, the condensed structure kuda barkona. This is number 1, 2, and 3 carbon atom. At the second carbon, there's substitution. This is addition reaction. So now acid catalyzed hydration. The unsymmetrical alkene iruvaga addition takes place according to Marconi curve. Direct agi apply madi. Now these to the central carbon atom you add the OH minus, the negative part of that particular reagent. That is water there. So the product nodally. So this is isobutene. Remember that. Look at the product now. So now this carbon atom, the central carbon atom, is going to be tertiary, bonded to 3 other carbon atoms. To that the alcoholic group is linked. Product common name tertiary butyl alcohol. Adashtu ಸ್ವಲ್ಪ lower members ಯಾವುದೇ ಒಂದು ಗ್ರೂಪ್ ತಗೊಂಡ್ರು ಹೋಮೋಲಾಗಸ್ ಸೀರೀಸ್ ನಲ್ಲಿ ಎರಡು ನೇಮ್ ಗಳು ಆದಷ್ಟು ಫೆಮಿಲಿಯರ್ ಆಗಿದ್ರೆ ತುಂಬಾ ಅನುಕೂಲ. ಕಾಮನ್ ಸಿಸ್ಟಮ್ ನಲ್ಲಿ ಬರುವಂತಹ ನೇಮ್ ಮತ್ತು ಐಪಿಎಸ್ ಸಿಸ್ಟಮ್ ನಲ್ಲಿ ನಾವು ಐಪಿಎಸ್ ಟ್ರೈ ಮಾಡೋಣ ನೋಡಿ. ಈಗ 1 methyl group is taken as a substituent, 2 methyl propane-2-all ಅಂತ ಎಂಡ್ ಅಪ್ ಆಗುತ್ತೆ. So therefore the option D is the correct answer. Okay, next one, the addition of halogens to alkenes is an example of. So kind of reactions in the first practice ಮಾಡ್ಕೊಳ್ಳಿ. Free radical substitution ಕೂಡ ನಿಮಗೆ alkenes ನೆನಪಿಗೆ ಬರಬೇಕು. Alkenes do answer the free radical substitution reaction. Nucleophilic addition you have studied this year. This is the characteristic reaction of carbonyl compounds. Both aldehydes and ketones happily undergo nucleophilic addition. Addition with HCl, they form cyanohydrin. Remember that. Let's come to the nucleophilic substitution. Nodiga. So now you have studied this is the alkyl halide, conversion of alkyl halide into alcohol. The easiest reactions carrying out as a result of the attack of the nucleophile, because carbon atom to which halogen atom is bonded is electron deficient. This particular question is this option. So electrophilic addition is going to take place in case of addition of halogens to alkenes. Look at this, it forms a complex like this. When the cyclic halonium ion form out there. Questions the addition of halogens involves the formation of. Then involves the attack of nucleophile from the, so now which results the product. So therefore critically, so now it it is because of electrophilic addition, both in case of alkenes and alkynes. So therefore option C is the correct answer. Now, which of the following is the incorrect set of conversion? This question is conversion mentioned. Which is incorrect? This is all going to be in the form of bond line structure. So now 1, 2, 3, 4. This is how we write the alkyne, right? Linear geometry, that is butane. In presence of the reagent, ideas, this is Lindlar's catalyst. So this is a selective reduction. Now, alkyne and alkene stop reduction. So now, whenever the reduction is carried out in presence of a particular catalyst, especially in this method, now addition takes place from one side. So hagagi cis is this is how we write the cis. It indicate the two methyl group on the same side of the carbon-carbon double bond. This is perfect conversion, those students. Other type method C the option C the this is once again this is going to be the butane in presence of sodium liquid ammonia. Lithium kuda mention birth reduction. So now look at this. Indicate this is transformed. The two methyl groups are on the opposite side. This is exactly correct. So whenever the conversion of alkane is being carried out to alkene in presence of sodium and liquid ammonia, this is trans addition going to be. So therefore, this is the perfect conversion. And this is the cis conversion, the first one. And B method nodi, illi vicinal dihalide. The bromine atoms are present on the adjacent carbon atom in presence of zinc, right? It forms respective alkane with the liberation of zinc halide. Zinc bromide remove out. Therefore, respective alkene is going to form. Once again, beautiful method to convert dihalide, vicinal dihalide into alkene. Let's come to the D option. Sodium in diether, this is Wood's reaction. So hige nan barkoltini illiga. So whatever the given reactant is being, so now Na takoltini. Plus I write that thing in the same fashion. Look at this. So removal of NaCl will be easier. I take 2 Na here. So now I write the product now. Yerdu alkyl in the same branching form join ಮಾಡಬೇಕು. ಇಲ್ಲೇನು ಹೇಳಿದ್ದಾರೆ hexane form ಆಗುತ್ತೆ ಅಂತ. This is the wrong product going to be. ಇಲ್ಲಿ ನೋಡಿ, this is substituted alkene. Numbering ಮಾಡಿ 1, 2, 3, 4, 2, 3 dimethyl butane is the product. Therefore, option D is the incorrect set of conversion being mentioned. That's our answer. So with that, I'll move on now. N-heptane, when passed over the mixture of vanadium pentoxide and alumina at 773 Kelvin and refined degree Celsius, it forms something. So now this is the aromatization reactions. A conditions then quickly hexane onwards, they form the benzene and its homolog. Right? Hexane matu ನಂತರದ ಕೆಲವು alkeneಗಳನ್ನು ನಾವು aromatic hydrocarbon convert ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ನಾವು heptane ತಗೊಂಡಿದ್ದೀವಿ remember. So ಹಾಗಾಗಿ options B ಅಲ್ಲವೇ ಇಲ್ಲ. It's cycloheptane. It's being ruled out now. So let's work out on heptane ತಗೊಳ್ತೀನಿ ನೋಡಿ. ಈಗ heptane ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ ಹೇಳಿ. So now look at this. The first ಇಲ್ಲಿ cyclohexane ring form ಆಗುವಾಗ 1 molecule of hydrogen is removed. Further it removes 3 mole of hydrogen. So now it forms toluene. So now n-heptane on aromatization reactions the product form is going to be toluene. So therefore option C is the correct answer. Illi nodi, Next question now, dear friends. An alkene acts on ozonolysis gives 2 mole of a ketone. 2 mole of ketone form agutte. Molar mass 58 unit anta helidare. Okay, let's see that. Namiga 58 unit andre enagutte anta nodona. It is ketone anta aitu. One ketone CO unit. Now that adradu mass, look at that, 16 plus 12, 28 hige work out ಮಾಡೋಣ. That means 30 is being remaining now. CH3 mass illondu CH3 ಹಾಕೋಣ, illondu CH3 ಹಾಕೋಣ. CH3 ಅಂದ್ರೆ 15, 12 plus 3. Therefore ಈಗ ನೋಡಿ ಏನಾಯ್ತು ಅಂತ 58. You have to come to the conclusion. ಆ ketone ಯಾವುದು ಅಂತ first ನೀವು, yes, you have to find out which is that ketone. Look at this, molar mass 58 unit ಇದ್ದಾಗ definitely this is going to be acetone ಅಥವಾ propanone. We already studied. ಹೀಗಿದ್ದಾಗ ನಾವು ಎರಡು fragmented molecules ಯಾವುದು ಅಂತ ಬಂದ್ರೆ it will be easier. ನಾನು ಹೀಗೆ ಬರ್ಕೊಳ್ತೀನಿ. Look at that. ಎರಡು propanone I am writing in that fashion. ನೀವು ಇದೇ ಟೈಪ್ ರಿಯಾಕ್ಷನ್ ಮಾಡಿ remove the oxygen and join that alkyl unit with the double bond. ಇದು ನೋಡಿ, this is what is the alkene X going to be. So numbering from one end, 1, 2, 3, and 4. Therefore 2,3-dimethyl butane. So now ಇದೊಂದಿಷ್ಟು ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ವೆರೈಟಿ ಆಫ್ ಕ್ವಶನ್ಸ್ ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ತುಂಬಾ ಅನುಕೂಲ ಆಗುತ್ತೆ. Okay, therefore option D is the answer. ನೋಡಿ, ಈಗ sequence of reactions mention ಮಾಡಿದ್ದಾರೆ. Sequence of reaction is being given. It started from calcium carbonate. ಈಗ that is being heated. P ಅಂತ ಒಂದು product ಬಂದಿದೆ. Further is being heated the coke. Q is the product which on reaction with water, R and S. ಅವರು ಏನು ಹೇಳಿದ್ದಾರೆ ಹೇಳಿ? You have to find out that products both R and S. ನಾವು ವರ್ಕೌಟ್ ಮಾಡೋಣ. ನಾವು ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಕರೆಕ್ಟ್ ಆಗಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಎರೋ ಮಾರ್ಕ್ ಮೇಲೆ ಏನ್ ಮಾಡಬೇಕು ಅಂತ ಹೀಟ್ ಮಾಡ್ತೀನಿ. Now if you heat calcium carbonate, it removes the molecule of carbon dioxide. The decomposition reaction, it forms P. Adre P ಏನಾಯ್ತು ಹೇಳಿ? Calcium oxide, which further reacts with coke. ಏನು coke ಹೇಳಿ? Amorphous form of carbon. It combines with coke, right? That is on heating. So now it removes the carbon monoxide. So the product formed is calcium carbide. So QCaC2 anta that reacts with calculated quantity of water. Well-known reaction of the preparation of alkanides. ಇಲ್ಲಿ ನೋಡಿ ಏನು ಬರುತ್ತೆ ಅಂತ. This is converted into C2H2, acetylene ಅಥವಾ ethane ಅಂತ ಕರೆಯೋಣ, and calcium hydroxide. ಇಲ್ಲಿ R and S ಎರಡನ್ನು ಕೂಡ ಕೇಳಿದ್ದಾರೆ. ನಾವು ಆಪ್ಷನ್ ನಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡಿ ನೀವು ಆನ್ಸರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ನೋಡಿ ಆಪ್ಷನ್ ಸಿ ದಲ್ಲಿ C2H2 plus CaO ಅಂತಿದೆ. ಸೊ ಹಾಗಾಗಿ these are all the things you might commit the mistakes. Therefore ಯಾವುದು ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಸೂಟ್ ಆಗುತ್ತೆ ನೋಡಿ, ಆಪ್ಷನ್ ಎ ದಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. R is C2H2 and S is calcium hydroxide. Okay, with that let's move on to the next question. Arrange the following alkanes in the increasing order of their boiling point. So ಹೀಗಿದ್ದೊಂದು ಕ್ವಶನ್ಸ್ ಗಳು ಇದ್ದೇ ಇರುತ್ತೆ. The variety of organic compounds ಇರಬಹುದು. ನಾನು ಇಲ್ಲಿ alkanes ತಗೊಂಡಿದ್ದೀನಿ. It could be aldehydes, it could be ketones, it could be haloalkanes. ಇಲ್ಲಿ ಎರಡು ಕಾನ್ಸೆಪ್ಟ್ ನೆನಪಿಟ್ಟುಕೊಳ್ಳಿ. So first concept is it could be whatever kind of organic compound. As far as the boiling point is concerned, ಇದು ನೋಡಿ, boiling point always increases with increasing molar mass. ನೀವು methane ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, methane, ethane, propane, butane ವರೆಗೆ ಬರ್ರಿ. Butane having higher molar mass. So therefore butane should have higher boiling point than the other members. So it's quite obvious. ನೀವು molar mass ಅನ್ನು increase ಮಾಡ್ತಾ ಹೋದಾಗೆ the van der Waals force, the intermolecular force of attractions is going to be increasing. Hagagi it requires higher energy to break that force which is present between the molecules. Hagagi obviously boiling point increase ಆಗಲೇಬೇಕು. So now that's the first thing. ಇಲ್ಲಿ ನೋಡೋಣ ನಮಗೆ ಏನು ಮಾಡಿದ್ದಾರೆ ಹೇಳಿ. ಇಲ್ಲಿ pentane ಕೊಟ್ಟಿದ್ದಾರೆ, butane ಇದೆ. ಇದೇನು ನೋಡಿ 2-methyl propane. So now it is being given, I write like this. This is pentane, right? Having same ಒಂದೇ ಕಡೆಗೆ ಎಂಡ್ ಆಗುತ್ತೆ. Butane ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಇನ್ನೊಂದು 2-methyl propane. This is isobutanane. 2,2-dimethyl propane. Look at this. This is neopentane. This is neopentane. ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ನೆನಪಿಟ್ಕೊಳ್ಳೋಣ. As far as the branched isomers ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ಅಂತ. Among the isomers, look at this. The boiling point decreases with the branching. The branching ಜಾಸ್ತಿ ಆದಾಗ ಏನಾಗುತ್ತೆ, it assumes the spherical shape. The surface area decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Therefore, one more molecule here going to be now as a result of that. But ಇಲ್ಲಿ ನೋಡಿ ಇನ್ನೊಂದು the surface area ಹೇಗಾಗುತ್ತೆ ನೋಡಿ, there is a larger proportion of the force going to be involved between the molecules. Now look at this, the force going to be present is going to be weaker and weaker. Hagagi less energy is applied to break that force present between the branched isomers. So hagagi usually straight chain compounds have higher boiling point. ಇಲ್ಲಿ options very clear. Idu first one, this is first one going to be pentane, highest ಇರಬೇಕಿಲ್ಲ, right? ನಂತರ pentane ಇದೆ ಇನ್ನೊಂದು ಫಾರ್ಮ್ ಆಫ್ ಬ್ರಾಂಚ್ಡ್ pentane. Look at this 2,2-dimethyl. This is neopentane ಅಂತ ಕರಿತೀವಿ. ಇದು ನೆಕ್ಸ್ಟ್ ಬರಲೇಬೇಕು, ನಂಬರ್ 2 ಆಪ್ಷನ್ ನೆಕ್ಸ್ಟ್ ಬರಬೇಕು. ಸೊ ನಾವು ಇಲ್ಲಿ ಬ್ಯೂಟೇನ್ ಮತ್ತು ಬ್ರಾಂಚ್ಡ್ ಬ್ಯೂಟೇನ್, ಐಸೋಬ್ಯೂಟೇನ್ ಇದೆ. ಸೊ ದಿಸ್ ಕಮ್ಸ್ ನೆಕ್ಸ್ಟ್. ಲೀಸ್ಟ್ is going to be the branched butane. Therefore options ಯಾವುದು ಅಂತ ನೋಡೋಣ. This is going to be the first option A. So pentane is having higher boiling point than the neopentane, 2,2-dimethyl propane, then butane, and then 2-methyl propane. So therefore remember this, these two concepts. Boiling point increases with increase in molar mass, and among the isomers the boiling point decreases with branching. Please remember these two aspects. Okay, so now which of the following does not form sodium alkynide? So this is once again special kind of reactions that you cannot observe in case of alkenes and alkanes. Adu enu anta kelidre, the acidic property, reaction with bases. No, I can expect in case of alkenes and alkanes. Alkynes are acidic anta ಹೇಳ್ತೀವಿ. ಹಾಗಾದ್ರೆ ಯಾಕೆ ಅಂತ ಕ್ವೆಶ್ಚನ್ಸ್ ಬಂದೇ ಬರುತ್ತಲ್ಲ. Look at this, the carbon atom of carbon carbon double bond, they are going to be sp hybridized. They are more electronegative. They pull the bonding pair of electrons towards themselves. You know that. So hagagi the hydrogen atom connected to the bonded to the carbon atom of carbon carbon double bond in alkynes going to be more and more acidic. Ethanal ಎರಡು hydrogen atom ಇದೆ, both are going to be acidic. ಒಂದು ಕಡೆಗೆ ನಾನು R ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ this results plus effect, ಆಗ acidic strength ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. So now this is what, ಈಗ ನೀವು hydrogen acidic ಇರೋದ್ರಿಂದ you can carry out the reaction with base like sodium. So the hydrogen bonded to the carbon atom of carbon-carbon triple bond can be removed in the form of hydrogen. This is the most important reaction of alkyne with bases. Now resulted salt again karitivi heli, ethyne takondre sodium ethanide, for example, sodium propanide, sodium butanide. So we call it sodium alkanide. Look at this. So now monosodium, disodium by removing 2 hydrogen atom from ethyne. Propane ನಲ್ಲಿ ಒಂದು acidic hydrogen ಇದೆ propine ನಲ್ಲಿ, you can remove sodium propanide. ನಾನೀಗ butane ಗೆ ಬಂದ್ರೆ, look at this, this is the butane going to be sorry, this is the butane, this is 2-butane, this is going to be, look at this, this is 1-butane. Now ಈ 1-butane ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಇಲ್ಲಿ definitely the acidic proton going to be. Whereas here, in case of 2-butane, there is no acidic proton. So therefore, but2-ine no way can form the salt with the base. Acidic character hege variation agutte anta order nodona. Ethyne is going to be strongly acidic. Then propane, yake heli illi ಒಂದು methyl group bantu. It operates inductive effect. So therefore, ಅಲ್ಲಿ supply ಆಗಿರೋದ್ರಿಂದ electron density, electron is being supplied towards the carbon atom of carbon carbon double bond. So now the polarity is going to be electron density ಅಲ್ಲಿ increase ಆಗಿಬಿಡುತ್ತೆ. Hence the acidic nature will be decreased. But1-ine ನಲ್ಲಿ the ethyl group is going to be bonded to the one carbon atom of carbon carbon triple bond. But2-ine ನಲ್ಲಿ acidic proton ಇಲ್ಲ, acidic hydrogen ಇಲ್ಲ. Therefore definitely it cannot form that particular salt called as alkanide. Butanide anta alli form agalla. Therefore option D is the answer. Okay, now which is the major product in the following reaction? Now ಇಲ್ಲಿ ನೋಡಿ, benzene, which is treated with N-propyl chloride in presence of anhydrous aluminum chloride. Again, reaction here. This is Friedel-Crafts alkylation. The role of AlCl3, it forms an electrophile. To generate the electrophile, AlCl3 is required. First step in form right? This is a propyl carbocation. This is primary carbocation. Look at this. One thing and particularly, it's a tendency of each and every matter to stay in a stable form. Illi options ide nodi to change over aglike. Second question, so now hydrogen atom, definitely it can shift to the carbon atom number 1. This is hydride shift along with its electron. So therefore, look at this. Look at this one. It is changed into secondary carbocation because of 2-1 hydride shift. So secondary carbocation is more stable. So that is going to exist in the reaction mixture. Hence, look at the product. No way the propyl benzene. The first option propyl benzene by mistake ನಿಮ್ಮಿಂದ ತಪ್ಪಾಗಲಿ ಅಂತ ಕೆಲವೊಮ್ಮೆ ಇಂಥ ಆಪ್ಷನ್ ಗಳನ್ನ ಫಸ್ಟ್ ಆಗಿ ಇಟ್ಟಿರ್ತಾರೆ. ನಿಮ್ಮಿಂದ ತಪ್ಪಾಗಬೇಕು ಅಂತ questions easy ಇರಬಹುದು, but you need to think a lot. So now therefore the answer here is not going to be propyl benzene because of the formation of the isopropyl carbocation, that is secondary carbocation, because of rearrangement. It forms the product isopropyl benzene is a product. Okay, so now I hope you could get some concept, students. So now I think you are with me. With that concepts being discussed so far, I'll move on to the next question. Okay, so the answer is isopropyl benzene here. Which of the following statement is true? ಇಲ್ಲಿ ನೋಡಿ, ಹೀಗಿದ್ದಂತ ಕ್ವಶನ್ಸ್ ಕೇಳಿದಾಗ ನೀವು ಏನ್ ಮಾಡ್ಬೇಕಂತ ಕೇಳಿದ್ರೆ, ಡೆಫಿನೆಟ್ಲಿ ಯು ನೀಡ್ ಟು ಗೋ ಥ್ರೂ ಆಲ್ ದ ಆಪ್ಷನ್ಸ್. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಹೇಳಿದರೆ ನ್ಯಾಪ್ಥಲೀನ್ ಈಸ್ ನಾಟ್ ಎ ಪ್ಲೇನಾರ್ ಮಾಲಿಕ್ಯೂಲ್. ಎಸ್, ನ್ಯಾಪ್ಥಲೀನ್ ಇಸ್ ಅರೋಮೆಟಿಕ್ ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ. ಅಂದ್ಕೊಳ್ಳೆ ಇದು ಪ್ಲೇನಾರ್ ಆಗಿರ್ಲೇಬೇಕು. ದ ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ದಿ aromaticity. So therefore definitely the naphthalene is planar and it satisfies the Huckel's rules also, 4n plus 2 pi electrons. So therefore first option is not true antaitu. Second nodili, the benzene, all carbon bond lengths are same anta. ನೀವು ಇಷ್ಟೇ ಪಾಯಿಂಟ್ ಅನ್ನು ನೋಡಿಕೊಂಡು ಕರೆಕ್ಟ್ ಅಂತ ಹೇಳುವಂತಹ ಚಾನ್ಸಸ್ ತುಂಬಾ ಇರುತ್ತೆ. ಬಟ್ ಮುಂದೆ ನೋಡಿ ಹೇಳಿದ್ದಾರೆ ಇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 133 picometer. ಲುಕ್ ಎಟ್ ದಿಸ್. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಏನಾಗುತ್ತೆ ಅಂತ. ನಾವು let's move on to that thing now. In case of benzene, we know that all the carbon bond lengths are same, but not that value going to be. Nodiga carbon single bond idre the bond length 154 picometer ಅಥವಾ 1.54 angstrom unit. Carbon double bond idre 133 picometer. They mentioned that value there. It is in between. It's an intermediate with that of carbon single bond and carbon double bond. Therefore, bond length should be 139 picometer. So, our statement adu kuda wrong ide. Nanತರ ನೋಡಿ, cyclopentadienyl cation is an aromatic compound ಅಂತ ಹೇಳಿದ್ದಾರೆ. Cyclopentadienyl cation. So now NN ಇದ್ರೆ ಸರಿ ಇತ್ತು ಏನೋ. ಇಲ್ಲಿ cation ನೋಡೋಣ ನಾವೀಗ. It is planar ಇದೆ. 4n plus 2 electrons fulfill ಆಗಬೇಕು. Huckel's rule, you know that 2 pi bonds ಇದೆ. 2 pi bond in the 4 pi electrons ಆಯ್ತು. It should 4n plus 2 ಎಷ್ಟು electrons ಬರಬೇಕು? 6 pi ಬರಬೇಕು. So therefore it is an anti-aromatic compound, non-aromatic compound it is. ಅದು ಕೂಡ ಕರೆಕ್ಟ್ ಇಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಹೋಗೋಣ, cycloheptane cation. So now look at this. Cycloheptane cation ಅಲ್ಲಿ 3 double bonds ಇದೆ. Therefore 3 into 2 6 pi electrons ಆಯ್ತು. Exactly correct. They said 6 pi electrons. So therefore it is aromatic also, fulfills all the. So now planarity and that number of electrons also, this is aromatic compound, contains 6 pi electrons. All conditions fulfill agutte. So therefore their correct answer is going to be option D. Okay, let's move on now. The students, next question now. Which of the following group activates the benzene ring? Okay, so now look at this. Illi ಒಂದು ಪಾಯಿಂಟ್ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. as far as the substitution, benzene ring, now there's a benzene ring going to be. If there is a substitution as far as the benzene is concerned, substitution on R and it could be anything. Based on the substituted group, the activity of benzene is depending on. Iga, a group, if it induces, if it results plus R or plus I effect. So now, if any group which results a plus under resonance effect plus inductive effect, they activate the benzene ring. Simple example OH anta group idre, NH2 anta idre, they all result plus R effect, resonance effect. They move the electrons towards the benzene ring. So automatically benzene becomes electron rich, activate agutte. Athwa plus I effect yavadu induce madutte heli, for example alkyl group like methyl group. On the other part, if any group is resulting minus negative resonance effect, minus R, minus I, negative inductive effect, negative resonance effect. Now, for example, look at this. I'll give the example for minus R. Look at this. This is CHO aldehyde group. Minus I yavadu X. That is all halogens. They deactivate. Illi, let's come to the points now. Option C. COR is ketone. The carbonyl carbon is bonded to the carbon atom of benzene ring. So it withdraws the electron from the benzene ring. Benzene is going to lose the pi electrons. So inactive aglebeku. Look at this. COR, it's an ester group. This induces minus R. This induces minus R. Iga Cl andre, this is X halogen. This results minus I effect. This is also partially going to deactivate. So alkoxy group, this is the group going to result plus R effect and hence activate the benzene ring. Okay, let's come to the next question, dear students. And look at this. This is C2H2 to C6H12 conversion. The type of reactions involved stepwise in the figure. So now, let's work out now. C2H2 this is C2H2 is converted into C6H12. C6H12 look at this. This is cyclohexane. This is cyclohexane. This is being converted. The type of reactions involved stepwise respectively. So this is cyclohexane. This is also having the formula CnH2n. Now, this cannot be carried out in one step. So I have to convert acetylene into benzene. This can be done easily, which further can be converted into cyclohexane. Let's see. Now, acetylene I pass into red hot iron plate. Again, 3 moles of acetylene undergo polymerization, cyclic polymerization, it forms benzene. Now, nantra, they add on to hydrogen. In benzene, yes, if you carry out the reaction with hydrogen in presence of nickel, this is addition reaction. Step 1 in the reaction involved there is cyclic polymerization in the addition reaction. That's how you have to think, students. The reactions, this is benzene converting into cyclohexane, benzene converting into BHC, the typical examples of addition reactions of benzene. Therefore, option D is the correct answer. So let's move to the next question now. So now, which of the following reaction of alkene is usually carried out in presence of HIO3? This is halogenation reaction. So now, as far as the reaction of alkanes with the halogens is being concerned, it follows this order. With fluorine, the reaction is too violent. With iodine, reaction is very slow. So, adenation is slow and so fluorination is too fast and moderate the rate with the chlorine and the bromine. So iodination HI is going to be one of the product. Now this is being a powerful reducing agent which reduces H3I, thus obtained, and backward reaction setup. Reversible reactions are. So our job is we need to destroy the HI which is obtained in the reaction. And in the destroy ಮಾಡಬೇಕು. So therefore, the best method by using some oxidizing agents like HiO3, HNO3 ಕೂಡ use ಮಾಡ್ತೀವಿ. ಕೆಲವೊಮ್ಮೆ HGO mercuric oxide ಕೂಡ use ಮಾಡ್ತೀವಿ. Look at this, they convert HI into iodine. ಏನಾಯ್ತು ಹೇಳಿ, iodine concentration ಜಾಸ್ತಿ ಆಯ್ತು. Therefore, equilibrium shifted towards the right. So product formation is favored. Therefore, option D is the correct answer. This is a sequence of reactions. Once again, ಇಲ್ಲಿ ನೋಡಿ sequence of reactions mention ಮಾಡಿದ್ದಾರೆ. Starting compound ಕೂಡ ಹೇಳಬೇಕು, last final product ಕೂಡ ಹೇಳಬೇಕಾಗುತ್ತೆ. C3H4. Dear friends, I think you are with me now. ನೋಡಿ ಇದು ಏನು ಅಂತ ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. C3H4 ಏನ್ ಹೇಳಿ, this is propine, right? This is propine, CnH2n -2. ಇಲ್ಲಿ ಎರಡು ಸೆಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಒಂದು ಕಂಡೀಷನ್ ಅಲ್ಲಿ alcoholic OH and further sodamine. So both these reactions meant to carry out dehydrohalogenation. ಅದನ್ನೇ ಮತ್ತೆ ಸ್ಟ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಒಂದಿಷ್ಟು ರಿಯೇಜೆಂಟ್ ಬಗ್ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಐಡಿಯಾ ಇರಬೇಕು. ವಾಟ್ ದೇ ಆರ್ ಮೆಂಟ್ ಟು ಕ್ಯಾರಿ ಔಟ್, ಅವು ಯಾವುದಕ್ಕಾಗಿ ಬಳಸ್ಕೊಳ್ತೀವಿ ನಾವು ಅಂತ. ಸೊ ದರ್ಫೋರ್ ಏನಾಗಬೇಕು ಇಲ್ಲಿ, ಸ್ಟಾರ್ಟಿಂಗ್ ಕಾಂಪೌಂಡ್ ನಲ್ಲಿ ಹ್ಯಾಲೋಜನ್ ಇರಬೇಕು. ಎರಡು ಸ್ಟೆಪ್ ನಲ್ಲಿ ಯಾವುದರಿಂದ, ಇಲ್ಲೂ ಕೂಡ HX ಅಂತ ಬರೀತೀನಿ, ಹೈಡ್ರೋಜನ್ ಹ್ಯಾಲೈಡ್, ಇಲ್ಲೂ ಕೂಡ. ಸೊ ದರ್ಫೋರ್ ಇಟ್ ಶುಡ್ ಬಿ ಡೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ dihalo compound. Usually vicinal is preferred here, and the adjacent carbon atom ಗೆ ನಾವು halogen atom. It could be 1,2 bromo ಇರಬಹುದು, 1,2 C3 ಇರೋದ್ರಿಂದ, propine ಇರೋದ್ರಿಂದ ಏನಿರಬೇಕು, reactant ಕೂಡ 3 carbon atom ಇರಬೇಕು. Therefore, the 1,2 dibromo propane, right? Okay, I take 1,2 dibromo or 1,2 dichloro. Therefore, ಇಲ್ಲಿದೆ ಆಪ್ಷನ್ A ಮತ್ತು C ದಲ್ಲಿ ಡೈಬ್ರೋಮೋ ಅಂತಿಲ್ಲ, ಇಟ್ಸ್ ರೂಲ್ಡ್ ಔಟ್. ನೋಡೋಣ B ಮತ್ತು D ದಲ್ಲಿ ಇರೋದನ್ನ ಪ್ರೊಪೆನಾಲ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ, ಫಸ್ಟ್ ಆಪ್ಷನ್ ಬಿ ದಲ್ಲಿ. ನಂತರ ಪ್ರೊಪೆನೋನ್, ನಂತರ ಏನಾಗುತ್ತೆ ನೋಡಿ, ದಿಸ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್. ಸೊ ನಾವು ವಿಸಿನಲ್ ಹ್ಯಾಲೋಜನ್ ಆಟಮ್ being removed there. ಇಲ್ಲಿ ನೋಡಿ ಪ್ರೊಪೈನ್ ಬಂದಿದೆ. ಲುಕ್ ಎಟ್ ದಿಸ್. ಈ ಕಂಡೀಷನ್ ಏನ್ ಹೇಳುತ್ತೆ ಹೇಳಿ, alkynes are immiscible with water. They do not react with water easily, but with presence of catalyst mercuric sulfate, so reaction is carried out very easily. It forms the enol form ಅಂತ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ನಾನು ಹೇಳಿದ್ದೀನಿ ಸ್ಟೆಬಿಲಿಟಿ ಕಡೆಗೆ ಯಾವತ್ತು ಡ್ರೈವಿಂಗ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ ಅಂತ, ವಿಚ್ ಚೇಂಜಸ್ ಓವರ್ ಟು ಪ್ರೊಪೆನೋನ್. ದಟ್ಸ್ ಅ ಟೌಟೋಮರೈಸೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ therefore final product is propanone. It's a beautiful kind of reaction. Therefore option C is the correct answer. So therefore A ಮತ್ತು D ಇಲ್ಲಿ ಆಗ ಬರಲ್ಲ. Therefore B ಮತ್ತು C ದಲ್ಲಿ now C is going to be the correct option. 1,2 dibromo propane and propanone is going to be the correct answer. Yes. Next question now, I'm going to be identify the correct set of reagents used in the following conversion. Ili propine to propane 1,2-diol. So now propane takondu propane 1,2-diol one step nalli ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗುತ್ತೆ ಅಂತ ವಿಚಾರ ಮಾಡಬೇಕು. No way. 1,2-diol ಅಂತಂದ್ರೆ, so from propane to propane 1,2-diol is easy to carry out. Therefore ಅಲ್ಲಿ ಏನಾಗಬೇಕು ಅಂತ ಕೇಳಿದ್ರೆ, I have to convert propine into propane and then to propane 1,2-diol. So propine to propane, there are several methods, but ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡೋಣ. There Lindner's catalyst ಬಗ್ಗೆ ಆಪ್ಷನ್ಸ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, right? Now I use this thing. So now definitely you can convert propine into propane by using Lindner's catalyst. Selective reduction ಮಾಡಿ propine ಅನ್ನ propane convert ಮಾಡ್ತೀನಿ, right? Now propane to propane is a simple oxidation reactions. Bayer's reagent ಅಂತ ಕರಿತೀವಿ. Dilute KMnO4 ಅನ್ನ add ಮಾಡ್ತೀನಿ. So now decolorization of that takes place. This is a test to detect the unsaturation. Therefore, what's the option there now? The option is going to be D. So now going to be the correct answer. So ಹೀಗಿದೊಂದು ಕ್ವಶನ್ಸ್ ಇದ್ದಾಗ ಕರೆಕ್ಟ್ ಆಗಿ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ very much easily you can give the correct answer. So next questions, moving on to the magnitude of the torsional strain in rotamers, in the conformers. There's a free rotation around the carbon-carbon single bond nಮಗೆ ಗೊತ್ತಿದೆ. Torsion strain ಅಂದ್ರೆ ಏನು ಅಂತ ಬೇಕಲ್ಲ. Now look at this, we write it like this. ಹೀಗೆ we predict that thing, right? For example, this is what is called as a staggered conformation, where hydrogen is a staggered conformation of ethane. Hydrogen atoms are far away. Now, this bond is called as a dihedral bond. Now, torsion strain, whenever the near the CH bonds are going to be very nearest, present on the adjacent carbon atom, there exists a repulsive force. So that affects the stability of the conformer. That's now torsion strain and the criteria. So now that torsion strain depends on only one aspect called as dihedral angle. Dihedral angle kadame idu bitre now the eclipsed form anta kariತೀವಿ. So minimum dihedral angle going to be more torsional strain and going to be more unstable that form. Haga now staggered form is stable anta ಹೇಳ್ತೀವಿ. These are in between forms called as skew forms, and this is how it changes. Energy form hege changes ಆಗುತ್ತೆ ಅಂತ eclipse ಬಂದಾಗ ತುಂಬಾ high level of energy content going to be more stable, more unstable, and moving on to the staggered form going to be stable with a less energy content. ಯಾಕಂದ್ರೆ torsion strain minimum ಇರುತ್ತೆ. Therefore answer ಏನು ಹೇಳಿದೆ students? The torsion strain in rotamers depends on dihedral angle. Okay, so now this is the next question going to be the products obtained by the ozonolysis of 3,4-dimethyl heptane. Idu another way, iga alkene kottidare, you have to give the answer what are the products obtained anta. Naniga hept 3 anta helidare, nanu heptane bartini 1 2 3 4 5 nodi 6 7 same ending onde kadege end carbon atom ide. They say hept 3 in. I'll count 1 2 3 here. Look at this, nanu illi double bond haktini. Now they say 3,4-dimethyl 1 2 3 1 2 3 4 5 6 7. Illondu methyl group ide and illondu methyl group ide. 3,4-dimethyl. I break here, right? So therefore substitutions is a complete substitution. So now therefore the product form here is going to be, look at this. Now I write it like this. This is butanone. Whenever there's a complete substitution, I said hige practice madi, I write like this. This is once again 2 ketones are going to be produced. Idu butanone aitu. Look at this. Idu 1 2 3 4 5. This is pentane 3-one. So therefore option D is the correct answer. How many isomers are possible with the formula C4H8? So now for C4H8 ಎಷ್ಟೆಲ್ಲ possible ಇರಬಹುದು ಅಂತ. One nodi I'm writing like this. This is 1 butene. Look at this. This is cis form nalli kuda ನೆನಪಿಟ್ಕೋಬೇಕು ನೀವು. Look at this. Another form and one more form you already studied. These 4 alkenes are going to be produced. Ali alkenes ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರೆ option C would have been the answer. But ಇನ್ನೊಂದು, look at this. Cyclobutane. Look at this. I'm writing one more. All angle in the isomers barivaga. So therefore 6 isomers are going to be possible here. So therefore D is the correct option. And next question going to be identify the correct order of reactivity in the electrophilic substitution reactions of. So a concept same ide. Whenever the plus R or plus I inducing group idre, they activate the benzene. Activated benzene ring idre electrophilic substitution is easier, remember. So adanna ಸ್ವಲ್ಪ ಗಮನವಿಟ್ಟು ನೋಡಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲಿ toluene ಇದೆ ನೋಡಿ. This is definitely the plus I inducing. Hyperconjugation ಕೂಡ ಆಗುತ್ತೆ plus I. Therefore it increases the electron density in the benzene ring. So therefore 3 can be easily substituted toluene. ನಂತರ ಏನಿದೆ ಹೇಳಿ ನೋಡೋಣ ಇಲ್ಲಿ. This is partially deactivating because it induces minus I effect, and least is going to be this minus R effect from NO2 group. Therefore option ಏನು ಬರುತ್ತೆ ಹೇಳಿ. Now toluene can easily substitute it, then benzene, then chlorobenzene, then last is nitrobenzene. Yes, students. So I think you could understand some of the concepts. I'm happy if you get some points, and with that if you could able to solve some more questions, this is going to be very much useful. So now at the fag end, students, only I can say that don't stress, do your best and forget the rest. So now, good luck. This is what we are all hoping for. So now, Hagagi, Yella questions Galano, it case some Patanta questions Galano, workout Madi, Mumbarova, Parikshagali, Yeshasu, Tamadagli, and Raista, Nani session and Mista Idini, dear students, all the best. May God bless you. Thank you, one and all.